Okay, good morning. Deviation of real gas from ideal behavior. Real gas, those gases which do not obey all the gas laws at all conditions of temperature and pressure are called real gases. Ideal gases, those gases which obey all the gas laws at all conditions of temperature and pressure are called ideal gases. Volume occupied is not negligible. Volume occupied is negligible in case of the ideal gas. Also, force of attraction is not negligible in case of real gas, but in case of ideal gas, force of attraction between molecules are negligible. Example, Boyle's law. In case of real gas, the force of attraction is not negligible. For example, van der Waals equation. We'll study about van der Waals equation in detail and later on. Okay. Ideal gas obey all the gas equation at all conditions of temperature and pressure, but in fact, there is no any ideal gas in existence. So our concern is about the real gases which obey the ideal gas equation only at the high temperature and low pressure. Study of deviation of real gases from ideal behavior on the basis of PV versus P graph. This graph shows difference between the ideal gases and real gases. For example, helium, hydrogen, methane, carbon dioxide, and nitrogen. PV versus P graph. If we consider Boyle's law at constant temperature, PV equal to constant. At constant temperature, a graph of PV versus P should be a straight line parallel to pressure axis for ideal gas, but real gas do not obey the general principle and deviate from the expected straight line. Gases such as hydrogen and helium show a gradual increase in deviation from ideal behavior with increase in pressure. Gases such as carbon monoxide, methane, carbon dioxide show decrease in PV value reaches to a minimum value, then increases continuously with increase in pressure. Deviation of gas from ideal behavior on the basis of PV equal to nRT. A gas which obey ideal gas equation PV equal to nRT at all conditions of temperature and pressure is called ideal gas. Actually, none of the known gas obey the ideal gas equation under all conditions of temperature and pressure. Hence, concept of ideal gas is only hypothetical gas have nearly ideal, however, at low pressure and high temperature. Appreciable deviation from the ideal gas behavior are observed at low temperature and high pressure. A gas shows deviation from ideal behavior when the product of pressure and volume is lower or higher than that of the expected value for ideal gas. The condition of deviation are PV observed, nRT or Z is less than 1, negative deviation. If Z is greater than 1, positive deviation. To describe the behavior of real gas, ideal gas equation should be modified PV equal to Z and RT, Z equal to PV and RT, where Z is compressibility factor for ideal gas, compressibility factor Z equal to 1, and for Uh, okay, sorry. Z equal to PV equal to nRT, where Z equal to compressibility factor. For ideal gas, Z equal to 1, and for real gas, Z not equal to 1. Effect of pressure variation on deviation. At very low pressure, for all these gases, Z is approximately equal to 1. This indicates that at very low pressure, real gas shows nearly ideal behavior. If the pressure is increased, these gases shows the deviation from ideal behavior. Effect of temperature on deviation. A graph is the complexity factor Z versus probability of finding the molecules at a different temperature for nitrogen gases. Uh, this is the at minus 100 degrees Celsius, 60, 25, and 100, 400 degrees Celsius, decreasing the temperature and deviation in the graph, effect of temperature and deviation. It is clear that from the shape of the curve that the deviation from the ideal behavior becomes less and less with increasing temperature. If we increase the temperature, it becomes the ideal. Conclusion: from the above discussion, we conclude that at the two pressure and fairly high temperature, real gas shows nearly ideal behavior and obey ideal gas equation. At low temperature and sufficiently high pressure, a real gas deviate significantly from ideality and ideal gas equation is no longer valid. The study of deviation of real gas from ideal gas behavior on the basis of P versus B graph. A graph of pressure versus volume or real gas compared with the ideal gas. For any real gas, if a graph of pressure versus volume plotted on the theoretical basis, the nature of the curve is shown in figure represented by AB line and the graph plotted on the experimental basis, the nature of the curve is represented by a AB line. It is the reveal It is revealed that the experimental value of volume is greater than the theoretical value at high pressure or real gas shows the more volume than that of expected ideal condition. Cause of deviation of real gas from the ideal behavior. The deviation of gas laws are based on the kinetic theory of the gas, which are based upon the certain assumption. There must be wrong with the certain assumption. A careful study shows that the high pressure and the low temperature, the flowing assumption of kinetic theory gas becomes invalid. The volume occupied by a gas molecule is negligible as compared to the total volume of the gas. The force of attraction or repulsion between the gas molecules are negligible. These assumptions are true only if pressure is low and temperature is high. However, if the pressure is high and the temperature is low, the gas molecules come close together under this condition. The volume occupied by a gas molecules is not negligible as compared to total volume of the gas. The force of attraction or repulsion between the gas molecules are not negligible. Okay, it's all about deviation of a real gas from ideal gas and study of deviation real gas from the ideal behavior on the basis of PB versus P graph, deviation ideal gas ideal behavior on the basis of PB equal to nRT. Thanks for watching and request you all like, comment, share, and subscribe. Thank you. Thank you.